Question is coming. Okay, so general structure, it's a particle case. This is the master equation. This master equation is an equation which is set in infinite dimension on a set of probability measures. So basically, don't look at the details. Non-mathematicians should certainly not look at the details. But basically what you have is now some kind of equation which is of this partial differential equation style, type, meaning that you have derivatives in various variables, and some of those variables are themselves an infinite dimensional object M. In fact, this is an infinite dimensional equation, which is very bad news even for mathematicians. And let me emphasize that when those two economists, Krussell-Smith, and Krussell is a very important figure in economics because he also belongs to the Nobel Prize committee in economics. So he tends to get a lot of attention from his fellows economists. But anyway, they of course didn't write those equations. They were setting up a set of rules for the behavior of the individuals in an economy, and in fact the type of models which are behind are such equations. Okay, so I certainly don't want to emphasize, but exactly as in the simple example before, where M was the unknown, so now M even becomes a variable, and this is some kind of U of X of M and T is some kind of optimal evaluation function. That's the best you can do, knowing that the population is in a state M and that your attributes are X. So M reflects how the population is. X is a set of attributes. Yes, please. I'm sorry? Yes. So U is like if you had no M dependence, the U would be the value function associated to the Hamilton-Jacobi equation defined by the Hamiltonian. Okay? So it's an evaluation function. Evaluation functions. It's a value function. So there is a criteria. So you should think that U is the optimal criterion, optimal value you can get for a population which is in state M. And X is a list of attributes that's part of your models. X is how you're going to describe the agents. So forget the details. I mean, that's irrelevant. X is like is how you describe the agents. So it could be the age, it could be the wealth, it could be the geographical location. So that's part of your model. How am I going to describe the agents? Well, by a set of coordinates, and that's X. Okay? Fine. So this is an equation that's very bad news. Fortunately, it's an infinite dimensional problem. And there are many, many extensions and variants, but this is already a monster equation.